halogenation of an alkene in an inert solvent. We see here that we have added 2 halogens across the alkene, and that halogen could be either bromine or chlorine, which means in these reaction conditions, the X2 could be either Br2 or Cl2, molecular bromine or molecular chlorine. An inert solvent means a solvent that is not reactive. And in this case, we mean it's not going to be nucleophilic. And so the inert solvent that we're talking about would be either carbon tetrachloride or dichloromethane. Okay, let's look at the products and the reactants here. So we are starting with an alkene, and we are forming a dihalide. And we should notice the stereochemistry here as well. We see that one of these is going into the plane of the page and the other halogen is sticking out of the plane of the page in a trans relationship. So we say that this addition reaction would be an anti-addition. So anti-addition means that the 2 groups added to opposite faces of the alkene. Previously, we have seen syn addition with both hydrogenation and hydroboration oxidation. And in both of those mechanisms, the syn addition occurred because of a concerted mechanism. Both of the groups were transferred at the same time and thus to the same face of the alkene. In order to get the groups to be anti, that means that both of these bonds cannot be formed in one mechanistic step. So let's take a look at the mechanism for this reaction. So we have our starting alkene, and I will use bromine for this example. So I'm going to draw molecular bromine. I'm not going to include the solvent because we said that it is not reactive. It's not playing a role in the mechanism then. Okay. So in this reaction, the pi bond is a nucleophile, so it will do a nucleophilic attack on the molecular bromine, and this will expel the bond to the other bromine, and at the same time, the bromine is going to come back and attack the developing positive charge at this carbon. So this is going to give us a cyclic intermediate. Okay, and here's our cyclic intermediate, and the positive charge here is on the bromine rather than on one of the carbon atoms. So this bridged intermediate is known as a brominium ion. And so that brominium ion, I've drawn it as sticking out of the plane of the page. It could just as easily be going into the plane of the page, but it is for sure sitting on one face of this molecule. When the bromide ion that was released here attacks, because bromide is a nucleophile, and this brominium ion, which its positive charge is an electrophile, the brominium ion is blocking one side of the alkene, so this bromide ion is going to have to attack from the other side. So it's going to attack a carbon atom and then break open this brominium ring. And so we're giving electrons to the bromine, which is quenching that positive charge. So this attack here is going to be attacking from approximately 180 degrees away from that brominium ion. And that's what gives us this trans stereochemistry in the product, right? So it's coming in from the opposite side, so that's going to end up on a dashed bond here in a product. So there's the dash bond, the bromine that just formed, right? And we broke this bond, but the bond between the other carbon and the bromine is still intact, and we've shown it sticking out of the plane. And so it is still sticking out of the plane of the page.